Alright, this tutorial is going to cover the second half of lessons in the first unit for Republic Schools computer programming curriculum. So far we've already covered some of the basics of movement and how to import sprites and backdrops, so I've skipped over a couple of those steps. Today we're going to be dealing with how to draw our own sprites. We're going to be dealing with how to make sprites communicate with each other. And we're going to be dealing with how to do what's called debugging, or fixing mistakes. So first we're going to talk about drawing our own sprites. You saw Scratch comes with a pretty decent library of some pre-made sprites, but very often we're going to want to be able to make our own objects. So instead of clicking the create or load from library, we're going to do paint new sprite. And this is going to load up our editor. And when we edit here, everything that we do is going to show up on the screen over here as well. We're actually literally just making a sprite. So there's two different modes that you can do this in Scratch. And the first is called bitmap mode, and that's what it defaults to. So we're going to look at bitmap, and then we're going to look at the other mode, which is called vector mode. So in bitmap mode, what that means is that every pixel of color is just simply one flat image. So let's take, for example, we're going to make two snowmen. So I'm not going to use yellow. I'm going to use like a nice gray color. And for the purposes of this demonstration, I'm going to scroll down. I can zoom in and out over here, and I can also scroll. So I'm going to scroll down to sort of the bottom. And I'm going to make my first circle. And now notice this is actually an ellipse, not a circle. But if I hold down Shift, it'll automatically snap to be a circle. So I'm going to draw the base of my snowman. Now I want the center filled in, so I'm going to get my paint bucket tool, and I'm going to fill the center of that circle. Now it's going to fill everything within a boundary. That's how it knew how much to do. Now I'm going to make my next circle, but instead of making it hollow and then filling it in, I'm going to choose to make it autofill down here. So now we're going to make our second circle. And right when I let go, I can move this object around. But as soon as I click off and that border goes, notice this is now just one flat image. These aren't two separate objects. If I feel like this is a little bit off to the right, I can't just like grab it. I can take my select tool and select a region. But since these overlap a little, if I try and move that, notice I'm cutting off the top of that circle. So this is one of the big drawbacks of dealing with bitmaps, is that it's sort of, the concrete dries very quickly, so to speak. So we're going to draw our last object, which is going to, of course, be our head. I'm going to pop that on place. And then lastly, we're going to draw two lines sticking out from our snowman. There we go. And there we go. And then we're going to draw some eyes. And we'll use, actually, let's use our paintbrush tool. So this just allows you to draw. That's what I start off with. So I'm just going to plop two little eyes down here. And now we have our first snowman. So we've already seen the first big drawback of bitmaps. The second big drawback of bitmaps is that if you try and make an object larger, notice that this already, you can see the edges of the circles are kind of rough and granulated. It's not a smooth circle. But now watch what happens if I make this larger. If I take the entire image and select it and then blow it up, now that sort of rough edges, I mean, look at the top of his head right there. You can see everything looks very like cut out with scissors on paper. And the reason for this is each pixel is a square on your screen. So when we blow it up, those squares that were originally there get bigger. And so that causes what's called pixelation. Now we're going to make a second sprite. I'm going to move this guy over to the side. And we're going to draw a second sprite that's going to try and look pretty similar, but we're going to use bitmap mode, which we can do down here. And in bitmap mode, we converted to vector mode from bitmap mode. So notice our tools are over here to the right, and they look pretty similar, but there are some very significant differences. So just like before, I'm going to draw the base of my circle. And now already you can see on the screen the edges are smoother. I'm going to draw two more circles. And now what's really important, notice I'm not even being very careful about where I put these circles, is because each object remains separate in vector mode. So I can come back over here and move these around whenever I want. Even if it's, months after I made this vector, it'll still be a set of objects instead of one flat image. So now we're going to create our nose by grabbing an orange color. We'll kind of do the same thing with the line. There we go. And now we're going to fill the center of it. And notice it remembers the object. See how you can like select the different objects? It knows what each object is. And then lastly, we'll use our brush tool and we'll draw in our eyes just like before. Now I can set the width of the brush over here. So I'm going to get slightly bigger eyes. Now even these little brush dots, I can come back in here and move around later. So there we go. That guy's looking pretty similar to the last one that we made. Now I'm going to do the same thing I did before. I'm going to select the entire thing and I'm going to blow it up really big, even bigger than the last one. And notice how perfect all of the edges still are. Vectors use a complex set of proportions to recalculate what each of those pixels are supposed to be doing instead of just making the squares larger. And this provides a much higher quality image. So why even offer bitmap if it's less flexible and looks worse? The answer is because a vector requires a lot more processing on your computer. And if you start having several different objects on the screen that are all doing complex animations, and your vectors have lots of small little moving parts, things can get pretty complicated and start to slow down. So bitmaps are a little bit easier on the computer. It's less processing power. Vectors tend to look cleaner and better. The bitmap mode is also really popular. Minecraft is all bitmaps, all of the like squares and rough edges. So there's a little bit of style involved too. So that's the basics of drawing with Scratch. The only other thing I want to point out is that there's a bunch of different functions in Scratch that allow you to rotate images. This mark up here in the top right hand corner, Set Costume Center, determines where something rotates. So if I set this in the center and then I make this object rotate around in a circle, let's just turn it. Notice it's rotating about its center. If I now stop this and reset the center to, let's say, the head, now when I hit play, the object is going to rotate around the head. And this is something that, just depending on what you're trying to do, is pretty important. So now I'm going to delete those two sprites. And we're going to move on to the next major concept, which is allowing sprites to communicate to each other. I've imported this girl that's a soccer player for now and a soccer ball. And I want to make it so that the girl runs up, kicks the ball, and the ball goes in the goal. So your instinct, based on our previous tutorial, might be to grab her when the green flag is clicked. And then we don't need her to go forever. We just need her to move till the ball is kicked. I want her to move kind of slow since the sprites are pretty big on the screen. So we're going to kind of guess here, 50 times at 2 pixels. That looks like it's about 100 pixels apart. You can see down here the X value goes from about -180, so that might not quite be far enough. And let's make sure that she starts in the same place each time with her reset code. So let's run it and see if she gets to it. Yeah, that's pretty good. Perfect. Okay. Now we want the ball to move forward into the goal. So we're going to use very similar code, right? Make the ball move forward. So let's say that the ball moves forward just a little bit faster. Let's say like 4, and then, I don't know, maybe 160 pixels. Let's see how that runs. Oh, and let's make sure our reset code's there so the ball goes back. So now hey, it's a goal. Perfect. Okay, now here's the problem. The ball does not wait for the girl to kick. There is a block of code that says wait. However, this can get really, really complicated. Imagine if you're, several minutes into a gameplay and you're trying to make something wait until it gets past the finish line. Well, you don't necessarily know how long it's going to take. And so using wait is not really a very good way of accomplishing our current goal. Instead, and notice that even then, like, we'd have to adjust. So let's try 1.1, 1.2, and you don't really want to have to play guessing games like that. So instead, what we're going to do is we're going to take advantage of a new feature. Once the girl has reached the ball, which is after this repeat block runs, we're going to come up here to events, and we're going to do what's called broadcasting a message. So we're going to broadcast a message called kicked. And what this does, this message, it doesn't show up on the screen. The user doesn't see it. but every other sprite in your program is going to hear that message be broadcasted. So now for our ball, instead of moving when the green flag is clicked, I'm going to move when I receive kicked. And now when we run it, as soon as she stops, the message is broadcast. The ball gets the message, and the ball goes into the goal. And this is how we can broadcast different messages and allow sprites to communicate with each other. The last major thing that's covered in this whole second half of the unit has to do with what's called debugging. I'm going to go ahead and delete our soccer ball and our soccer girl. And I've set up two different situations that we need to deal with. The first of which is this bug, how appropriate. And my goal was to sort of recreate the challenge from the last tutorial, which was to make it move in a square. And I wanted it to move in a square that was 150 steps or pixels on each side. So I have this hidden right now just so it wasn't in the way. We're going to hit stop. We're going to show our beetle. And we're going to hit go. And clearly this is not what we were hoping for. So the act of debugging is taking like already written code and figuring out what's wrong with it. So to begin with, hopefully it should jump out that there is no reset code. We're not starting off at any place. So we realize, okay, well that's problem number one. It's going to pick up wherever it left off. So we're going to go ahead and add some reset code. Let's have it kind of start up here in the top corner. And notice now that I've moved it, the go-to values here have automatically changed to where it currently is. It's easier than having to type it in. And I also want it to start off pointing in the right direction. So let's see if that fixes the problem. Okay, so the reset code is good, but it's still spinning around. So since this is a video, I encourage you to like pause for a second, or maybe even go into Scratch and build this and see if you can figure out what's wrong. But I'm going to go ahead and move ahead with the solution. We're repeating 4 times. However, the problem is we're not actually repeating our movement. We're just moving 10 steps. And now I could change this to 150 steps, and we'll get a nice square. But we get back into that problem of where the computer's running the code faster than we want it to look. So hopefully you remember the technique of using a repeat block. And let's, I'm going to pull this out. And inside of this block, now this obviously isn't going to work because it's going to repeat 150 steps 10 times, which means it's going to go way off screen. Instead, since I'm repeating 10 times, I'm going to divide 150 by 10 to get 15, and now we have a beetle moving in a nice, perfect square. The second challenge to debug is this crab. And this one's a little bit more sophisticated, and the problem is a little bit less obvious. And I'm going to switch to a different background just because it's going to kind of help illustrate what we're trying to do. Okay, so we come back over here. We're going to hide our beetle again. It does not play a role in this. And we're going to show our crab. And my goal is for the crab to make it look like it's walking up and down the street. And I'm sort of taking advantage of some basic, I guess, laws of physics that as something moves away, it appears to get smaller. And I wanted the crab to kind of look like it was wiggling back and forth as it was walking. But the two problems that I'm running into are, I don't like how it's so like jutting back and forth, and I don't like how the costume change isn't even. It seems like it's like going to the left and then quickly hitting the right and back up. So once again, I'd encourage you to pause the video and see if you can see what's wrong here. From the first tutorial, we talked about what's called parallelism, which means we can run multiple blocks of code at the same time. And this like wiggling back and forth that I'm trying to accomplish, if you notice, we're actually just turning the sprite, and it's actually built into the same block of code that's causing our movement. So when I wait in between turns, I'm also pausing the movement. And that's what's causing it to seem like it's like jagged or glitching. So I'm going to take this out. Now notice change y by 10. This is the block where it's actually going up. Our y value is the vertical axis, and the size goes down. Down here is the block where y goes down and the size goes up. So let's just run this real quickly and see what it looks like. So there's our nice smooth movement, but we got to get our wiggle back on. So we don't need 2 of these anymore, do we? We don't have to put one here and one here. This is another advantage. We're actually saving resources by getting rid of blocks. all we have to do is just bring out some forever code. We pop our motion back in, and now our crab is moving back and forth without interrupting the movement. But we do actually still have one more problem. The way that it seems like it's just slapping to the right and then back up real quickly, it's not a smooth back and forth, is because we're only waiting from the right turn to the left. We're not waiting in the repeat back to the left turn. So I'm going to bring an extra wait block in here, set it to 0.1 also, and now our crab is walking nice and smoothly, moving back and forth. And we have successfully debugged, or in this case, I guess you could say decrabbed, the project that we had been given the code for. And that wraps up this tutorial. Thank you very much.